Okay, so today, for the second day of 1.6, we're going to solve systems of equation by elimination, any way you'd like for these three, and the bottom is all substitution. Now, if you look, the substitution is before the elimination, so it doesn't matter either way. For 7 through 9 on the top, you should find the best method. So in class today, we worked on these and the recording didn't work, so I'm recording it again by myself. So number 1 on the top of the worksheet was x plus y equaled 7 and x minus y equals -3. So doing elimination tells me that I need to eliminate a variable. This one is set up perfectly to just eliminate the y's. So that gives me 2x equals 4 when I combine the two functions, and then I divide by 2, and so x equals 2. And now I just substitute back the 2 back in either one of the equations. It doesn't matter which one. So I'm going to put it back in the top one. So I have 2 plus y equals 7. Subtract 2, so y equals 5. And I always write my problem as an ordered pair, so it's 2, 5. Okay, so the next problem I asked you guys to do is pick a problem that you thought looked kind of scary, and I think you picked 5. And see the answer there, we already had the answer together. But I'm going to rework the problem so you can see the steps again. So 5, and again we are elimination. So I have 4x minus 6y equal 26, and 5x minus 4y equals 8. So nothing is nice and neat to be eliminated. So I ask you which one, x or y, that you wanted to eliminate. And I think he told me that you wanted to eliminate y, if I'm not mistaken. There's no wrong answer here, just whatever. So if I want to eliminate my y's, I need to look at what is the smallest number they both go into. Now I can use a bigger number than the smallest, but it's just nicer not to have huge numbers. So the least common multiple of 6 and 4 is 12. And I need one of them to be a positive. So I'm going to choose to multiply the top equation by -2 to get 12, and the second equation by 3 to get 12. Biggest thing here, and I've helped to keep you since class, is you need to make sure that -2 is multiplied each term, not just one, all of them. So I have -8x plus 6y, not 6y, I just told you. I distributed my negative, but not the rest. So plus 12y equals -52, if I did my math right. And then 3 through, so I have 15x minus 12y equals 24. And then I just add the 2. So I get 7x equals, subtracting those two, I get -28. And divide by 7, so x equals -4. Now at this point I pick top or bottom. I have equivalent equations here, so this set of equations is actually exactly this set of equations, but I don't want to put it into bigger numbers. I want to put it into smaller numbers. I'm just going to choose the top one just because it's convenient. So I have 4 times negative 4 minus 6y equals 26. So I have negative 16 minus 6y equals 26. I'm going to add 16, and I get negative 6y equals 42. So y equals 7, or negative 7, excuse me, when I divide by negative 6. And then my ordered pair is negative 4 and negative 7. Now, if I want to check my answers, I just plug them back into the original equations. I'm going to do it here with this first one. I had 2 and 5, so if I plug 2 and 5 in for x and y, so I have 2 plus 5 is 7, and that's what it's supposed to be. And 2 minus 5 is negative 3. So it has to make both equations true. So moving down to the bottom part of the worksheet for substitution. Number 1 on the bottom is y equals negative x plus 4 and y equals 3x. So there's 2 ways we can do this. We can substitute one into the other, or they're both equal to y, so the transitive property says they're equal to each other. So I like to use the fact that they are equal to each other since they're both equal to y. So I have negative x plus 4 equals 3x. I add an x, and I get 4 equals 4x, and divide by 4, so x equals 1. And then I take it and substitute it back in, and I'm going to substitute it back into the second one this time because I think that looks a little easier to do. But it's really not hard either way. So I got x equals 1 and y equals 3. And if I plug it back into the original, x is 1, y is 3. So that means 3 equals negative 1 plus 4, which would be 3. Or 3 equals 3 times 1, which would be 3. The other way we could have done this problem, I'll do it both, is substitute it in. If I'm going to do that, I would choose to substitute the second into the first, just because it's me. So I would have y equals negative 3x plus 4. I'm sorry. Nope, we're going to stick with it this way. We're not going to do the other one. Okay, so 5 on the bottom is elimination. It was going to come out to be the same, and we were going to waste some time. So we have 6x minus 4y equals 18, and negative x minus 6y equals 7. Many of the problems on the bottom of the sheet are really worked out easily to accommodate substitution, and this one's no different. On the second equation, we have negative 1 for my coefficient on my x, so solving this for x would not be very difficult. I am going to add x and subtract 7, so I'm going to get that x equals negative 6y minus 7. And I'm going to use that and substitute it back into the first equation. So I have 6 times x, which is negative 6y minus 7, minus 4y equals 18. Distributing that 6, don't forget that. So negative 36y minus 42 minus 4y equals 18. I am going to add 42 over here and combine my like terms over here. So I have negative 40 y equals for some reason my brain wants to say that as wrong. Nope. Negative 40y equals 60. Not all peaches and cream always, right? So divide by negative 40, So y equals negative 3 halves. So I now have to stick with that negative 3 halves and substitute it right back into this original problem. So I have x, not the original problem, original solve for x, equals negative 6 times negative 3 halves minus 7. Well, a negative times a negative is a positive. That's good. 2 goes into 6 3 times. So I have 3 times 3 is 9, minus 7. So x equals 2. So my coordinate pair is 2, negative 3 halves. Now, I don't always check mine, even though I can, but I do when I get a fraction just to make sure I did it right. So I'm going to plug these two back into my original equations. So that would be 6 times 2 minus 4 times negative 3 halves, and it has to equal 18. So 6 times 2 is 12. A negative and a negative is a positive. 2 goes into 4 twice, so 2 times 3 is 6. And 12 plus 6 is 18. Now it also has to work in the bottom one. So that would be negative 2 minus 6 times negative 3 halves. And my answer should be 7. So a negative times a negative is a positive. 2 goes into 6 3 times. So I have negative 2 plus 9 equals 7. And negative 2 plus 9 is 7. So the last problem we were working on in class is number 9, and I did find my mistake, but I'm not going to share it with you. Hopefully you guys will find the correct answer, and we can go over it tomorrow.